In this video, we are covering 3 higher maths questions, one on vectors, a proof by induction, and an integral by parts. The first one says that ABCD is a parallelogram, where vector AB is negative I plus 2j plus 3k, and vector AD is 4i minus j minus 2k. And we need to find the area of the parallelogram ABCD, and we need to use the scalar product to determine whether the angle ABC is acute or obtuse. The area of the parallelogram can be found calculating the vector product between AB and AD and finding its modulus. To calculate the vector product, we use the matrix with unit vectors I, j, k in the first row, vector AB in the second row, and vector AD in the third row. The determinant of this matrix is I times the determinant of the remaining matrix, once we ignore the first row and the first column, minus j times the determinant of the matrix left, ignoring first row and second column, plus k times the determinant of the matrix left after ignoring the first row and the third column. You could stop the video here and check this small calculation. The vector product between AB and AD is negative I plus 10j minus 7k. That is 2 marks for you. The area is the modulus of this product. Using Pythagoras in 3 dimensions, we obtain the square root of 1 squared plus 10 squared plus 7 squared. The other 4 marks come from part B. We need to use the scalar product of the vectors AB and AD. This is as simple as multiplying component by component. Minus 1 times 4 plus 2 times negative 1 plus 3 times negative 2 equals negative 12. Since the answer is negative, the angle DAB must be obtuse. This is because the cosine of an angle bigger than 90, obtuse, is negative. And remember, the scalar product is linked to the cosine of the angle between vectors. If DAB is over 90, then ABC is less than 90. So ABC must be acute. This second one is a 6 marks question. Use mathematical induction to prove that 4 to the n plus 15n minus 1 is divisible by 9 for any positive integer values of n. To prove a statement by induction means showing that it's true for n equals 1 and showing that if the statement works for n, it also works for n plus 1. So first, we replace n with 1. 4 to the 1 plus 15 times 1 minus 1 equals 18, which is divisible by 9. Therefore, the statement is true for n equals 1. That is 1 mark for you. Now, assuming that the statement is true for n, we need to prove that it is true for the next term, n plus 1. 4 to the n plus 1 plus 15 times n plus 1 minus 1 can be written 4 times 4 to the n plus 15n plus 14. If 4 to the n plus 15n minus 1 is divisible by 9, means that 4 to the n equals 9k minus 15n plus 1. Expanding the bracket leads to the expression 36k minus 60n plus 4 plus 15n plus 14. Simplifying this, we obtain the expression 36k minus 45n plus 18, which is divisible by 9, since each term is a multiple of 9. This third one is a 5 marks question. Find the antiderivative of the arc sine of x with respect to x. We use integration by parts, with u equals the arc sine of x and dv over dx equals 1. If u is the arc sine of x, looking at my table of derivatives, not memorizing, no, du by dx is 1 over the square root of 1 minus x squared. If dv over dx equals 1, then v must be x. Using by parts, the answer is the same, that x times the arc sine of x, that part is u times v, minus the antiderivative of x over the square root of 1 minus x squared. This gives you 3 points. Solving the integral by substitution and writing the answer in simplified form gives you the other 2 points. If I let u equals 1 minus x squared, then du equals negative 2x dx. I'm going to replace all this into our integral. Integrating with respect to u is easier now, and the result is u to the power of 0.5 over 0.5. Cancelling the 0.5s and rewriting u in terms of x, the result is x times arc sine x plus the square root of 1 minus x squared plus c. If you haven't seen the previous videos on higher maths, I highly recommend you to. Until next Wednesday, happy learning!